Hi, my name is Ed Sweeney, and today I want to talk to you guys about my job and how I became an ocean scientist. I am currently working with the U.S. Geological Survey in the seafloor mapping group, and our office is in Woods Hole, Massachusetts on Cape Cod. The seafloor mapping group at USGS uses very sophisticated ocean mapping techniques to collect data that helps us understand the geology of the seafloor. We collect data mainly using something called sonar, which stands for Sound Navigation and Ranging. When we collect sonar data, this is often called geophysical survey or ocean mapping survey, and it helps us to make maps of the seafloor. We use sonar in ocean mapping by echo sounding, or really bouncing sound off the seafloor. It's almost like using a flashlight to see the bottom of the ocean, but instead of light, we use sound. If you know how fast the sound travels and how long it takes to go to the bottom and back, you can figure out the depth. Well, okay, it's a little more complicated than that, but that's the general principle. I grew up in New Jersey in a town called Cranford, which is not exactly on the ocean, but it's not far from the Jersey Shore. Growing up, my family and I loved being outdoors. We did a lot of hiking and went to the beach every summer. My mom and dad were avid beachgoers and body surfers. So when we went to the beach, we were pretty much always in the water. It really helped to develop my love for the ocean. As I got older, I started getting really into surfing and ended up lifeguarding at the beach in a place called Long Beach Island in New Jersey. It was pretty much the best job ever. My friends and I watched the ocean all day and would take turns surfing, body surfing, and paddling. I ended up going to college in Maine at a small school called Bowdoin College. When I got there, I didn't really know what I wanted to study, but my academic advisor, a professor named Ed Lane, told me that I should take his Intro to Geology class. Many of our labs were outside and on the water, so geology became the perfect major for me. Professor Lane had studied geological oceanography at Woods Hole Oceanographic Institute on Cape Cod. He became my honors project advisor, and it was really him that helped me get into ocean sciences. During the summer before my senior year, he and I did a project together mapping the sediments beneath Casco Bay, using sonar to image the sediment layers beneath the seafloor. The sonar instrument that we used was something called a seismic reflection profiler or sub-bottom profiler, which can image sediment layers beneath the surface to about 50 meters or about 150 feet. It's almost like taking an X-ray of the seafloor. The sound that the seismic reflection profiler makes travels down into the sediments and reflects off the different layers in the sub-bottom. Yeah, it's kind of crazy, but trust me, it works. It's almost like being able to take a slice of the bottom and look at it from the side, like when you drive past rock that has been cut to make a road. Once we collect the sub-bottom sonar imagery, we use it to find good places to take sediment core samples. Sediment cores are tubes of sediment that we pull out or extract from the seafloor for analysis. It's usually a pretty muddy job. After we collect the sediment cores, we split the core open and analyze the sediment layers. If we find them, we can use things like shells or wood in the sediments to figure out how old the sediment layers are. This is important because it will tell us when the sediments were deposited. Okay, so fast forward to the present. Like I said, I'm currently working at the U.S. Geological Survey in Woods Hole. A project that I've mainly been working on at the USGS focuses on understanding the geology off the coast of the Delaware, Maryland, Virginia region, which is an area known as the Delmarva Peninsula. This past summer, the USGS conducted an ocean mapping survey off the Delmarva Peninsula that lasted about 40 days. We collected sub-bottom profiles, bathymetry or depth data, side scan sonar data, bottom grab samples, and bottom photographs. Yeah, it was a lot of data. One of the coolest types of data from the summer cruise is side-scan sonar data, which I haven't really talked about yet. A side-scan sonar device is pretty much like how the name sounds. It's a type of sonar that sends sound out to the side of the sonar fish. Man, say that 5 times fast. The wide swath of sound bounces off the ocean bottom and can be used to identify different types of seafloor, such as mud, sand, or rocks. Usually, softer sediments like mud don't reflect much sound back and show up in darker tones on the sonar map. Harder things like rock reflect a lot of sound back and show up on the sonar map as lighter tones. By towing the sonar fish back and forth so that the side-scan sonar data overlaps, we can make a map or mosaic of the seafloor. This is sometimes called mowing the lawn. Once we complete the side-scan sonar survey, we can go back and collect physical samples of interesting features that show up in the side-scan sonar data. Usually we will take a grab sample or sediment core and collect bottom photographs or video so that we know what type of seafloor is in that feature. By identifying and analyzing these seafloor features, it helps scientists to better interpret the forces that help shape the seafloor, such as strong currents, glaciers, tides, storms, landslides, volcanics, seafloor spreading, subductions, things like that. If we understand how these forces have shaped the seafloor in the past, we can get a better understanding for the ocean and its impacts on the environment in the present and future. And then again, sometimes we just use our ocean mapping knowledge to find other things, like sunken treasure. Being an ocean scientist has brought me to unique and exotic places, has helped me to experience amazing opportunities, and to meet fun and adventurous people. I get to study something that I truly love and care about, and I feel like I learn something new and interesting almost every day. I'm still fascinated by the ocean, and I really don't think I could have asked for a better profession. Plus, at what other job do you get to cruise around the high seas and look for ports with really high structures to jump off? Okay, well, I hope you've enjoyed my presentation and learned a little bit about mapping the ocean floor. Thank you very much for watching. I realized